What's up, guys? It's been a minute. I'm back with a new project. This is my Mercury 850, 85 horsepower outboard that I picked up actually last summer for $300. It's a 1975, I believe. The serial number starts with 39. Mercury used a couple different ways to identify these motors throughout the years, and to the best of my knowledge, the 39 starting number indicates it's a 75, but they made these, I believe, from 74 to 76 with minor changes. Anyways, the wiring on this was completely shot. This is a new internal harness that I'm almost done hooking up. I've basically already connected things that were connected that I could tell from the old harness, and now I just have to use the wiring diagram to connect what's left. And yeah, what's already been done basically is I've verified that the motor actually turns over. So I've been spraying these cylinder holes pretty liberally with ATF fluid. Everyone uses something different. I like to use ATF fluid because it's similar in viscosity to engine oil, but ATF fluid also has a bunch of detergents in it and cleaners, since transmissions are designed to be self-contained with no fluid change. At least old automatic transmissions are. So the fluid naturally has more detergents in it than regular engine oil. At first, I could not get this engine to turn over electronically. I took the solenoid off here, starting solenoid, cleaned all the contacts top to bottom, made sure all the wires were clean, all the nuts were clean, shiny, and it still wouldn't go. So then I went ahead and took the starter off, took it apart, and these starters, I don't really know what the difference between these older starters and new starters are, but they are extremely easy to take apart and clean. There's literally, I think, probably 4 bolts holding this thing on. Well, technically 6. You got 2 at the bottom here, you got 2 over here on the right on the inside of the motor, and then you got 2 on the top. You take those out, this whole entire starter will drop out. Then you've got 2 super long bolts at the top here, and then you've got to undo these nuts at the bottom here because this is actually a stud. And then this whole thing, you give it a couple taps, this whole thing will drop out. And I've actually never had a starter apart, but this black section here is actually, this is the magneto part. So it's all magnetic in here. There's a copper winding inside here, and that spins around, and that's what creates the electricity that allows the motor to turn. And it was all very, it wasn't corroded, but it was all very dirty in there. So I took a wire wheel and literally just cleaned everything off, cleaned the whole entire copper windings off, cleaned off all the contacts in here. And so I got all the contacts in there nice and cleaned up. And I actually, the magneto part, the black part that goes around, that is magnetic. So if you stick any kind of real metal to it, or any kind of metal that reacts to magnets, the magnetic part, which was that black part that I showed you, the middle part is extremely sensitive to other metals. So all I did for that, instead of wire brushing it, because I don't really think you're supposed to wire brush magnets, I just cleaned it off with like dish soap and put it back together. And once I did that, it actually, I put power to the solenoid, and that thing cranked over viciously. Like it was super powerful. So that solved that problem. Right now, all I'm trying to do is get spark to the motor. So I gotta finish putting this wire harness on, and then I gotta do some diagnosis to figure out why it's not getting spark. This has been on the camera for like the past minute. If you're working on an old outboard, highly recommend you get one of these. They're extremely useful. They have diagrams, they have instructions for literally every single kind of service that you need to do on one of these, from simple maintenance to whole entire overhauls of different components, carburetors, ignition systems, replacing coils, replacing distributors, all that kind of stuff. So extremely useful. And so all I'm going to do now is I'm going to go ahead and start finishing installing that internal wiring harness. Gonna get these contacts cleaned up a little bit. So in marine applications, whether you're working on the hull of the boat or the motor of the boat, if you're using any kind of bolt or nut hardware, you should always be sure to use stainless, because it's not going to oxidize and it's going to last a lot longer than using literally anything else besides copper or aluminum. But those are soft metals. I've really only seen probably a choke bolt made out of, I think it was aluminum, maybe it was copper, I don't remember, but obviously that's too soft of a metal and it's not very common. So then the next available option is, like I said, stainless steel. Yeah, I mean, even just having a piece of regular steel on a boat for a couple months, if the boat's out near water, it's going to start gathering oxidation on it almost immediately. Now, just after saying that, I'm going to go ahead and put these non-stainless steel, just regular carbon steel bolts in here. And it's only for the meantime because I couldn't find stainless steel bolts in the right length and diameter at Lowe's. And these are just to hold the coil in, because it was missing 2 bolts. I only had 1, and it needs to have all 3 because one of them, or 2 of them actually, are used for grounds. So I'm going to go ahead and install these 3 bolts, and then we're going to just continue knocking out wires. When you're diagnosing electrical problems on really any motor, one thing that really helps to rule things out is making sure all your contacts are clean. That's positive, and especially grounds. Even if something isn't disconnected, it's always good practice to go take it apart, clean it, and make sure it's always good, because just because something's tight and together, wiring wise, doesn't mean it's not corroded underneath. And one way to quickly blast through to get through to good metal is to use one of these cheapo drills. I got this one at Walmart. I used a pretty coarse steel brush there, and steel is not as good of a conductor as aluminum or copper. So after you're done brushing something off, I always like to go through and just wipe it down with a cloth to get any kind of steel bits off there, to keep the continuity good. I just cleaned off this ground here for the coil. You can see this thing's pretty corroded, but that's more than enough metal here to get a good contact. So we're gonna keep on going through, cleaning stuff off and reconnecting it. So this is actually pretty interesting. It's not getting power to the distributor on that side, or the coil, or the left side of the switch box. And all three of the there's three posts on that side of the switch box, and they all come from the distributor. And whether I turn on give the engine power from the solenoid, the star solenoid, which is the big one, or the key on switch, which is this one right here, I can give power to either one of them, and either way there's no power to the coil here or either three of the posts on the other side of the switch box. So there's either a problem with the coil here or the distributor over there. But the coil gets power from the distributor. So right now I'm thinking it's probably the distributor, but we're gonna have to do more tests to verify that. All right, so I know this this red post is getting power here. So this green post needs to get power. It wasn't getting power to the coil. So what I did was I went ahead and I connected this green wire from the top post here to the red post to see if it was sending power to the coil. And this wire was getting hot, and it was not sending any power to the power post right here. It was not a closed loop connection. There was no power to the power coil after putting this green one to a post that I know had power on it. So at this point I'm going to go ahead and replace this green wire here. I have a similar gauge wire that I can run to this, and I'll go ahead and put this on the top post and see if that makes a difference. I don't have enough hands to show you, but when I had the green cable, the green wire on top of this red post here, and I powered up the internal harness right here, the engine was extremely slow to crank, and there was no continuity to the coil here. But after I removed the green wire and repowered it right here, there was an extremely strong connection on the continuity here. So that tells me that there is something wrong with this wire. So I'll go ahead and test it and see if I can show you guys. So I have this wire, this is the green wire connected to a green battery cable. So I'm gonna go ahead and connect this blue light to it and see if it makes a connection. And so, wow, yeah, it actually does make a connection. So that's kind of weird. And that's weird because I thought the connection was due to the green cable being bad, but it actually has a very strong electrical connection. It has the green wire flows current perfectly fine. So I'm gonna continue on with trying different stuff on here and see what I can come up with. So I think I did make a mistake here with my diagnosis, because if I'm not mistaken, the coil here gets power from the switch box on the other side. And then the power comes up through the bottom here, out the positive side here, and then connects to here. So in order for that to be a proper diagnosis, I need to send power to the other side of the switch box, and then, or more specifically, send power to the distributor and see if it comes out here, comes up through here, then out the positive side of the post, because I know for a fact all my grounds are good. So the coil is getting power continuity through it. It's got about 0.8 ohms, which should be okay for it to run. Switch box is getting power to it from the new harness, so everything with that is good. But no matter what I do, I cannot get power to generate from this distributor. And I accidentally broke this wire trying to pull it out from the center that goes to the coil. So I actually do have power. This top one's ground. These three are for the distributor. The brown lead here has continuity through it using this ground on the top, but there's no continuity through this middle one, the white one, to either of these. So I'm gonna have to do some more diagnostic work. Gonna have to get a DVA tester as well to finish testing all the different parts, the electrical parts on here, per how the C-Lock manual wants me to. And we're gonna need to take this out, take this distributor out, test this, and take the trigger out from inside of here, this whole entire unit, test that, and take this. I need to take the switch box out too, and again just test the continuity and resistance of all those in there. And I kind of want to take this apart to see what's inside of it, because if it's bad, it's going to be a lot of money to replace it anyways. Might as well see how it works and see if there's anything that can be done to fix it in the future. But I guess that ends part one of my $300 outboard. So it turns over, everything works great. Well, I'm not going to say that nothing works great. It turns over. That's about all we have going for us right now. It turns over. It's got a new wiring harness internally in it. 0 spark, and I haven't done a compression test yet. So that's going to be the end of part one of this. We are going to get that DVA tester, and next part I'm going to be taking this motor apart some more to test out those components I said. So I hope maybe somebody gets something out of this video, even though I didn't get it to spark yet. But stay tuned, because there's going to be more videos coming out soon.